All right, good afternoon. This will be the section 9 and 10 test review. So we'll go ahead and get started. We have a shape here, and it says it's a rhombus, where m, the measure of DCA, is equal to 3x plus 9. So DCA, that's this angle here, is equal to 3x plus 9. That's this angle here. And then it says that DCB, so DCB, that's the whole thing, is equal to 12x minus 6. And again, that's the whole angle. This whole angle is equal to 12x minus 6. So you can see that because this is a rhombus, of course, we understand, or we know that this diagonal, it bisects this angle down here. So if this is one side of this, then 2 times 3x, so 2 times 3x plus 9 equals 12x minus 6. We could have also written out that 3x plus 9 plus 3x plus 9 equals 12x minus 6. So again, 2 of these equals 1 of these. 2 of these equals 1 of these. So 2 of 3x plus 9 equals 12x minus 6 for the whole thing. So we get 6x plus 18 equals 12x minus 6. Subtract 6x. 18 equals 6x minus 6. I'm going to add 6 to both sides. And carry it over here, I get 24 is equal to 6x, x equals 4. Okay, so I'm partway down with the problem. I have that one, that equals 4. Now I'm looking for the measure of ADC. Okay, well I know that if this whole thing, we already said it was 12x minus 6, this whole thing is also 12x minus 6. So these two angles are the same, they're congruent, and these two angles are congruent. So I can plug this in, plug 4 in, so 12 times 4 minus 6, so that's 48 minus 6 equals 42. So this is also 42 down here. This is 42, and this is 42. So if this is 42, and we know that angles that are adjacent in our rhombus are supplementary, so this is 42, this has to be 138. 138. Okay. That's it for that problem. Also note that these two would be supplementary. So this is 138, like I said, this is already 42. This would also be 138. Rhombuses, the opposite angles in a rhombus are congruent. Okay. For the figure on the left, what is the perimeter? And what is the area? Well, the perimeter is easy. It's just 15 times 4, which is 60. Now the area, I want to make sure. So this is a rhombus, and there are two area formulas for a rhombus. Area equals base times height, and area equals, that's a 1, d1, d2 over 2. So the question is, which of these formulas do we want to use? So, do we have height? Can we use this first formula? Well, the height has to be perpendicular to the side, and so we don't know the height of our rhombus here. So if we were to turn it on its side, you can see that this is perpendicular to a base. We don't know this height, so we can't use base times height. That's assuming, if you use base times height, you're assuming this is a square. And there's nothing in here to show us this is a square. There's no right angle marks anywhere, and it doesn't say that it's a square. We don't know that the diagonals are equal, so we can't say it's a square. We don't know that the diagonals are perpendicular, so there are a lot of facts we don't know. So we're going to assume this is a rhombus because it does have 4 congruent sides. We can assume it's a rhombus. And so I have D1 here. I'm going to call D1 24. I need D2, which I don't know what it is. So D2 can actually be found by finding the other diagonal. So I need this diagonal here, and my diagonal is supposed to be straight for sure. And so I'm going to, when I look at the diagonals of a rhombus, I realize that it makes 4 right triangles. So I have 4 right triangles here, and 4 congruent right triangles. So if I look at just one of these right triangles, I know that I have a right angle here, and I know that if this whole thing is 24, I know that the diagonals of rhombus or rhombi bisect each other, which means that this is congruent to this and this is congruent to this. So if this whole thing is 24, that means that this is 12 and 12. So the bottom piece of my triangle here is 12, this is 15, making this 9. This is a Pythagorean triple. 3, a 4, and a 5. You can also find that by doing 12 squared plus, we could have called this b squared equals 15 squared. 144 plus b squared equals 225. B squared equals 81. B equals 9. Okay? B equals 9. So, if b equals 9, so that was just this piece here. I'm going to use a different color to try to highlight it. This is 9, then this piece here also has to be 9. And if this is 9 and this is 9, then the diagonal D2 must equal 18. So when I go back and plug this into my formula, here D1 is 24, D2 is 18, I divide by 2, and I get 216 inches squared. Determine the values of the variables in the isosceles trapezoid. So if this is an isosceles trapezoid, I know that if this is 8x, this is 8x. And I know that these are congruent because they are base angles. And I know these are congruent because they're base angles. And I know that these are supplementary, and these are supplementary. So, since these are supplementary, that means they equal 180. I can add them together and set them equal to 180. I get 20x plus 40 equals 180. 20x equals 140. X equals 7. Okay, so now I know x equals 7. I know that this angle down here is 56. If that's 56, this is 56. And if this is 56, then I know that this plus this equals 180. So if this is 56, then what do these have to be up here? Well, they have to be 124 and 124. So I'm still looking for m, so 3m equals 124. That means that m equals 124 over 3, or 41.3, repeating. Okay. So the next problem, rectangle what on a coordinate has the following characteristics? So WA can be represented by the equation and HT. So my first thing to notice here is that these must be the diagonals because they're not the vertices that are adjacent. It skips one. So what I'm going to do, I know I'm looking for the points, so I'm going to take these bounds. So this means that this line exists. So this is some positive slope with an intercept way up here. This slope of this line exists only between -8 and -1. -8 and -1. Okay? And this line, again, some line where I have an intercept of 42, which is way off the graph here, and a slope of 8. So also positive slope. So, and that's only between -5 and -4. So I need to figure out what these points are because I can't graph them on my graph and I do this graphically. So x equals -8. So what will my y equal? Y equals 4 over 7. X plus 60 over 7. So I'm plugging in 8 into my x. So y equals 4/7 times -8 plus 60 over 7. So y equals, this is negative 32 over 7 plus 60 over 7. This is 60 minus 32 is 28 over 7, which equals 4. So my point is negative 8, 4. Okay, that's 1. We got more to go. X equals negative 1. Y equals 4 over 7 times negative 1 plus 60 over 7. Y equals negative 4 over 7 plus 60 over 7. Y equals 56 over 7. So this equals 8. So my point is negative 1, 8. Okay. Switch colors for the other. That was, this was for my W and my A. Now I'm going to do for my H. So my H, so let's continue on here. So Y, so when X equals negative 5, Y equals 8 times negative 5 plus 42. Y equals negative 40 plus 42, y equals negative 2. So my point is negative 5, negative 2. And my other one is when x equals negative 4, y equals 8 times negative 4 plus 42. So y equals negative 32 plus 42, y equals 10. So my point is negative 4, 10. So I need to plot these points. So I'm going to go ahead and plot this over here. So I have negative 8 up 4, negative 1 up 8, negative 5, negative 2, and negative 4, 10. Alright, oops, I realized I made a mistake. This is negative 40 and positive 42 is positive 2. That's positive 2, okay? You can see I didn't have much of a shape here, so negative 5, positive 2 is right there. Okay. We are back on track. So we have what looks like a rectangle here, which is good because it says rectangle what? So everything. Okay, so it says to graph the diagonals, so I put in the diagonals and I have the outside of the rectangle, and I need to find the area. So the only way to find the area of this, or the way that I'm going to find the area of this, is I'm going to find the base and the height. I'm going to call this, or length times width, however you want to see it. So I'm going to find the length of this right here. So that's a 2 by 3, and this one is a 1, 2, 3, 4. This is a 4 because it's from negative 5 to negative 1. So that's 4, and then it's from 2 all the way up here until 8. So if I'm going from 2 to 8, I need to have, so 2 to 8 would be 6. Okay? So I can find my lengths like this. So the length of this is going to be 2 squared plus 3 squared. So 2 squared plus 3 squared. So it's going to be 4 plus 9 equals 13. Okay? So the length of this is going to be the square root of 13. This is square root of 13, nice and small, make it a little bigger. And then this is going to be 4 squared plus 6 squared, which is equal to 16 plus 36, right? And 16 plus 36 would be 40. And then, so 52. So this is the square root of 52. All right. So the area of this would be the area, I'm using base times height, or length times width, and that's going to be equal to the square root of 13 times the square root of 52, and 13 times 52 is the square root of 676, and I'm just going to figure out what that is. I'm just going to take the square root of 676, so 676. So it's perfect square. It's 26. 26. So I have 26 square units. All right. So A, B, C, D is a trapezoid with midsegment MN, M to N. The perimeter, the whole thing is 72. Okay. The length of AB is 3/4 the length of D. Oh, let me see. The length of AB is 3/4 the length of AD. All right, here. So we can see by the little lines, you want to be really careful looking at the markings on this. So this means this is congruent to this. So these double markings mean that this is 10. If this is 10, this is 10. If this is 8, this is 8. And so we read here that the length of AB is 3/4 the length of A to D. So the length of A to D, right, is 8 times 2 is 16. So AB equals 3/4 times 16. Okay, 4 goes into 16, 4 times, this equals 12. So A to B is 12. All right, and so so we have this is 12. Now we need M to N, and then we also need D to C. Okay, so let's see, where else? So we know that the whole perimeter is 72, right? So if we have, this is 16, this is 20, 16 and 20 and 12, whatever's left of the 72 must belong here, okay, because the perimeter is 72. So 16 plus 12 plus 20, so this is 10 and 10, so 28, plus 20 is 48, so we have 48, so the D to C must be 70 minus 48, okay? So that's 22. So we have D to C is 22. And you just want to make sure you haven't made any mistakes. So I'm going to say 16 plus 12 plus 20 plus our last length, 22, better equal 70. Oh, it's 72. I made a mistake. This should be 72. Our perimeter is 72 yards. Oops. So this isn't 22, this is 24. So this is 24. Okay, so let's make sure again. So all my sides should be congruent, or all my sides should equal up to 72. So 16 plus 12, 16 plus 12 plus 20 plus 24 equals 72. Okay, so this bottom side equals 24, they all equal 72. Okay, and I need M to N. So I know the formula for M to N. So that's my mid-segment formula. So 12 plus 24 over 2. So 12 and 24 is 36 over 2 equals 18. Last problem on this page. So the diagonals of a parallelogram intersect at 0, -3. So 0, -3, 1, 2, 3. And one of the sides of your parallelogram is bound by 1, 0. So 1, 0. And 4, -5. 1, 2, 3, 4. 1, 2, 3, 4, 5. All right. So this is like one of the problems on the worksheets. Okay. So that's one side, and we have our intersection right here on the line. So the question is, graph the parallelogram on your paper and find the coordinates and remaining vertices. So we know that our intersection is going to be, so this is our intersection, so let's connect them. Okay. And I'm not sure, oh, yep, there we go. So I'm not sure what type of parallelogram this is yet, but I can look at it and I can see that it's 1, 2, 3 over 1. So this is a slope of 3, and this is down 1, 2 over 1, 2, 3, 4. Okay, so down 1, 2 over 1, 2, 3, 4. So my slopes are not reciprocals of each other. So this is not perpendicular. But I'm going to go ahead and see what other options I have. So if the other vertices was 0, 0, that is not a possibility. -2, 0. Okay, that would not put my intersection in the middle of my diagram, which it has to be if it's in a parallelogram. Think about your pictures of your parallelograms. The diagonals are always, the intersection is always in the center of your shape. So it couldn't be that. -2, 0, 1, 2, 0. Couldn't be that. That wouldn't put us in the center. -5, 1, 2, 3, 4, 5. Up 5, 1, 2, 3, 4, 5. That would be super weird. That's not much of a shape there. That would not be in the center of my parallelogram. -4, 1, 2, 3, 4. -1. Oh, okay. That looks like that could be a continuation of that diagonal. And then, so that's a possibility. And then -5, 3. 1, 2, 3, 4, 5. 1, 2, 3. Up there. That wouldn't, my intersection would not be in the center if it's up there. That's a no-go. -1, 1, 2, 3, 4, 5, 6. Ooh, that looks pretty good. That puts the intersection in the center, or the midpoint of that, it looks like. We'll check that. And then -4, 0. 1, 2, 3, 4, 0. That doesn't look like the intersection would be in the center if the vertices was up there. So I think I have my 2 points. This one and this one. So D and F. I'm just going to check though. So I'm going to draw the rest of my diagonals. And for this to be a parallelogram, I need my sides to be parallel. So I'm going to check that. So I need this to be parallel to this side. Oops, sorry. This side needs to be parallel to this side. So the slope of this is up 1. So 1m equals 1 over 1, 2, 3, 4, 5, 1/5. This one is up 1 over 1, 2, 3, 4, 5. That's slope. Those two slopes are the same. And then we need these two slopes to be the same. So this is 1, 2, 3, 4, 5. So down 5 over 1, 2, 3. This is down 1, 2, 3, 4, 5 over 1, 2, 3. M equals -5 over 3. So that would be a parallelogram. So that makes it so that these two, D and F, are the correct vertices. All right. The diagonal of a rhombus can be modeled by the equation x equals -1. So if I have my coordinate plane, my equation x equals -1 is going to be a vertical line at x equals -1, and I'm looking for which one of the following could model the other diagonal. Select all that apply. This is super important. Select all that apply. So what I need is a horizontal line. Okay. So that means I need a y equals something line. All lines that are horizontal are y equals. So this has a slope of 1, so that can't be it. This has a slope of 1, that can't be it. Horizontal line, excellent. This would be a parallel line, not it. Y equals 8, horizontal line up at y equals 8. Could have done the y equals -4. So that's good. And then x equals 2, that would be over here. That's no-go. So that's not it. So C and E. JKLM is a parallelogram. What are the degrees of x and what is the measure of KLM? And I think that this is missing an M here. Okay, so KLM is this whole angle here, and we're looking for x. So we know that this line and this line must be parallel because it's a parallelogram. So we have, we know that K, we're just looking for KLM, so we know that this angle plus this angle must equal 180. So we know that consecutive angles in a parallelogram are supplementary. So it would be, this right here would be 60. So that's the answer here. So it's 60. And then we're trying to figure out what angle x is. So we know that if this is 120, this whole thing, M must equal 120. The whole measure equals 120. We're just looking for x. So we know that this is 15. This is 90. Okay, because it's a right angle. So 15 and 90 is 105. And if the whole thing is, we're looking at, the whole thing here, so is 180. So it would be 180 minus 90 plus 15. So 90 is 105. So that equals 75. Or you could have just done these two must equal 90, which is 75. So this is 75. And we know that this whole angle is 120, so 120 minus 75. Okay, so that equals 45. All right, that's that. So x equals 45. ABCD is a rhombus. The measure of angle B is x plus 15. The measure of C is 3x. Which statement explains why the equation 3x plus 15 equals 180 can be used to solve for x? So we know that these two together, they equal 180. We're saying, why can we do that? Just started to rain outside. It's pouring. So what allows us to do that? Well, we know that opposite sides of a rhombus are parallel. So we know that these are parallel. This is our transversal. We have same side consecutive angles. There we go. It's A. That's it. Solve for A, W, and X, and Y. The perimeter is 95 units. So A, we missed one. W, X, and Y. We don't have a W here. So there's an extra letter snuck in there. So we just need A, X, and Y. So if this is a kite, we know that kites have two pairs of congruent sides. So this would be A also. Okay. And we know that the perimeter is 95 units. So the whole thing is 95. We know this is 22 and this is 22. So if we're looking for A, we know that A plus 22 plus 22 has to equal 95. So this is 22 and 20, so that's 44 equals 95 plus 2 times A. So we have 51, and then that equals 2A. So we're going to divide by 2, and we get A is equal to 25.5. Okay. So we're asking for x is this corner in here. So what is this corner in here? And so we know that this is 94, then x would also be 94. Good. So this is 94, so this is 94 down here, 94. And we're wondering what is y. Y is this super obtuse angle here. So if this is 33, so we know the whole thing has to equal this one, this, and this. They have to equal to 360. So I'm going to do 360 is equal to 33 plus 94 plus 94 plus y. And 94 plus 94 plus 33 equals, so 360 equals 221 plus y. 360 minus 221 equals 139. So y equals 139. degrees. Solve for a, w, x, and y. Now there's our a, there's our w, right there. So we want to know what a is equal to, so we're going to use the mid-segment theorem. So a plus 70 has to equal 56. So, a plus 70 over 2 has to equal 56. So I'm going to multiply both sides by 2. I get a plus 70 equals 56 times 2. It's 112. Subtract 70. A is equal to 112 minus 70, so that's 42. If we're solving for W, if this is 55, again we have parallel lines. We know the midsegment is parallel to the bases. Then what we have here, this plus this are same side consecutive interior angles. So 50 plus what is 180? So this is just 180 minus 55, which is 125 degrees. X, so X is up here. So if this is 60 and we have parallel lines, we know that this plus this equals 180, so X equals 120 degrees. And then we're looking for Y. And again, if these are parallel, we know that Y and 55 are in the same place, so they're corresponding angles, so we know that this is 55 degrees. And we can say that this one is corresponding angles, and we can say that this is same side consecutive interior angles running out of room, and that was the same thing we found earlier. So good. Michael plots and connects the following points which best describe the quadratic. So once you plot the points, you have A, B, C, and D. You can see that this must be a trapezoid, and you can prove that by saying that it has one side. A square graphed on the coordinate plane has a diagonal with endpoints E, F. What are the coordinates of the endpoints of the other diagonal? You have E and F. Oh, that's an F. E and F. And these are the, it says the endpoints of one of the diagonals. So we want to find the endpoints of the other diagonals, and we're talking about a square. So first we need to find the midpoint of this diagonal to know how to go perpendicular to it. So first of all, the slope of this would be, we're going down, we're riding downhill, so it's going to be a negative slope, so it's going to be, we're going down 1, 2, 3, 4, 5, 6, 7 over 1, so its slope equals -7. We can put it over 1, so the perpendicular slope, M perpendicular, is going to equal +1 over 7. And we want to find the midpoint, so our two, let's put this here, so 0, 4, and this one is 1, -3. So the midpoint formula, let's say midpoint formula, is going to equal, we have xm, ym, so we have, it's the average of the x's, so we're going to add 0 plus 1 and divide by 2, and then it's the average of the y's, so 4 plus a -3 over 2, so we end up with xm, ym is equal to 1 over 2, comma, this is 1 over 2. So this is also known as 0.5, comma, 0.5, if that helps, because we need to graph that. Okay, so 0.5, 0.5, it looks like our midpoint's here. And we need to start there, and we need to travel out in both directions. So we need to go, we're going to go opposite of what we had here. So we're going to go one way, we're going to go. Okay, so I put my point a little low. It's got to be right there in the middle, right? 0.5, 0.5. And I want to go, this is my slope. So my slope of this diagonal was -7/1. My perpendicular slope is going to be the opposite reciprocal of that, which is 1/7. So I just want to go half. So instead of going up 1, I'm going to go up half, and I'm going to go over 3. So that's up my half, and then I'm going to go 1, 2, 3 plus 1 is 0.5. I guess I should use this color here. And then I'm going to do the same. So I'm going to go down the half and go 1, 2, 3 and a half. So I'm there. So my 2 points are 4, 1, 4, 1, and -3, 0. And then you can see that this should be a square, assuming everything lines up. All right. In kite A, B, C, D, find the following angle measures. So A, C, D, it looks like it's asking for, so assuming we have our diagonal in here, it's asking for this. So if the whole thing is 60, half of it would be 30. So A, C, D is just this part. It would be, this whole thing is 60, half is 30. This is 30 and this is 30. A, B, C. Okay, so if this is 30, this is going to be 22, and this is going to be 22, and I'm wondering what B is. Well, I know that this has to be 180, so I can do 22 and 30. So this is going to be 180 minus 22 minus 30, okay, which is 180 minus 52, so 128. So we have 128. And then we have B, A, C, I already answered that, that's 22. And A, D, C matches A, B, C because these angles are congruent in a kite. Kites have one pair of congruent angles, and so that would be 128. In which, I suppose it should say, in which of the following quadrilaterals are the diagonals perpendicular to each other? So that's a rhombus, that's a square, and that's a kite. The figure to the right is made up of two quadrilaterals. Find x, y, and z. Okay. So we have a kite on top of an isosceles trapezoid. And I know it's isosceles trapezoid because it has two legs that are congruent and one pair of parallel sides. And I know this is a kite because it has two sets of congruent sides. And so I can move forward. So if this is 105, that means this is 105. If this is 105, it says that this is also 105. And I know if this is 105, then this measure right here must be the supplement of 105. That must be 75. So let me do some here we go, 75. And x, so 105 and 105 and 24 subtracted from 360, so that's right here I'm filling out x, so x would be 24 plus 105 plus 105 plus x has to equal 360. So 105 and 105 and 24, so 105 plus 105 plus 24 equals 234, so 360 minus 234 is 126, so 126 plus x, 126, that's our answer, is what x equals. There we go. That was very messy. So 24, 105, and 105 is 234 plus x equals 360. So x equals 126. There we go. A little neater. And then I'm looking for z. Find the values of z. And z is just this base angle down here. So if 75 here, then z would be 70. And that concludes our review. So we finished 1 through 16. We just finished number 16. The other page to review, which I discussed with my class, you have a box here about whether or not the description below is true or enough to prove a parallelogram. Then below that, there is a proof, and this is the actual proof from the test, as well as the proof below it. We are not going over the proofs on the YouTube, but you are being given the proofs so you can study them. So if you have any questions, please let me know. On the back side, please draw a Venn diagram. This comes from page 206, I believe it is. So you're going to have a rhombus, a square, and a rectangle. Below that, you're going to have your trapezoid and your kite. And please put the area formulas and how you visualize the Venn diagram. And below that is a table so that you can draw the figures of each of the types of quadrilaterals for their area formula or area formulas. Talk about how their angles are related. Talk about how their diagonals are related, their adjacent sides, and then opposite sides. Anyway, good luck. I hope you all do very, very well. And let me know if you have any questions.